Welcome all of you. Today we will see opamp as inverting amplifier. So before we start the lecture, do like, share and subscribe the channel for more and more fresh content. So see, an opamp circuit that produces an amplified output signal that is 180 degree out of phase with the input signal. In other words, the output produced is inverted. Therefore, this amplifier is known as the inverting amplifier. So see the circuit diagram of opamp as inverting amplifier. We all know in the before lectures that when input which is to be amplified is connected to the inverting terminal, therefore this opamp is known as inverting opamp or inverting amplifier. So see the circuit diagram. The signal to be amplified has been connected to the inverting terminal via the resistance R1. So this is resistance R1. The other resistor R2 connected between the output and inverting terminal. This is resistance R2 which is connected to the output here and the inverting terminal of the opamp. This R2 resistance is called feedback resistance. As we know, feedback from output to the input. It introduces a negative feedback. The non-inverting terminal of the opamp is connected to the ground. See, ground is connected. As the opamp is an ideal, its open loop gain tends to infinity and input impedance is also infinite. The negative sign to the open loop gain, here open loop gain is AV is equals to minus infinity. Minus sign indicates that it is the inverting configuration. The output is amplified and inverted version of the input signal because this is inverting amplifier. So see waveforms of this inverting amplifier. As we know, inverting opamp like that, inverting amplifier, same waveforms are there. This is the input signal we applied or input voltage that we applied to the inverting terminal. And this is the output voltage that we gain from the output of inverting amplifier. So as we know, the output voltage is inverted. Therefore, this positive peaks inverted. So this positive peaks inverted and we get the negative peak. We get the negative peak here and this negative peak inverted and we get this positive peak. Therefore, this is the waveform of inverting amplifier. Then see the expression. We can derive the expression for gain of inverting opamp. So firstly, we all know that output voltage is equals to gain into the difference between the, or we know that output voltage is equals to gain into the input voltage. But see here, input voltage is nothing but the difference between these two terminals, inverting and non-inverting terminal. So here V1 is the voltage produced in negative terminal, at negative terminal of opamp, and V2 is nothing but the voltage produced in at positive terminal of the opamp. Therefore, we can write input voltage is nothing but the difference between the two input terminals. Therefore, we can write VD or voltage difference as V1 minus V2. Therefore, V output is equals to AV, that is voltage gain, into V1 minus V2. Therefore, we can write VD, that is voltage difference, as V output upon the voltage gain. This mod represents that voltage gain never negative. This is open loop voltage gain. And as we know, an open loop gain of an opamp is infinite. Therefore, this voltage difference is equals to V output upon infinite. Therefore, it is 0. Therefore, we know that VD is equals to 0 means V1 minus V2 is equals to 0. As the non-inverting terminal is connected to ground, that is V2 is equals to 0. Here see, our non-inverting terminal, this terminal is grounded, means this V2 is equals to 0. Therefore, here this V2 is equals to 0 means V1 is also equals to 0. Therefore, V1 is equals to 0. Thus, inverting terminal, here see, this inverting terminal is not grounded actually, but from the equation we derive, it can be 0 or it is supposed to be 0. Therefore, this concept is called as virtual ground concept. See, I can write here. From the equation we derive V2 is equals to 0. Therefore, V1 is equals to 0 because of VD is equals to 0, or V1 minus V2 is equals to 0. Therefore, this concept that inverting terminal supposed to be 0 or at 0 potential, this concept is called as virtual ground concept. This is virtual ground concept. Then see, since our input impedance is infinite, the current input impedance is infinite by the characteristics. Therefore, current going into the opamp will be 0. Therefore, the current passes through R1 will also pass through R2. See here. See, input impedance is infinite. Therefore, suppose input impedance, therefore current does not pass through the opamp. Therefore, current passes through this R1 and this R2 will be same. Therefore, as voltage V1 equals to 0, input voltage also here we can derive V1 is equals to 0. The input voltage Vi across the voltage R1. Therefore, input voltage Vi is produced across the resistor R1, and output voltage is produced across the resistor R2. Therefore, we can write the expression Vi. Therefore, we can write the expression Vi, that is input voltage, is equals to I into R1, and for the output voltage is equals to minus I into R2. This minus indicates the inverting terminal. Then expression for the closed loop gain. This AVF represents the voltage gain with feedback. F stands for feedback. Therefore, this is closed loop gain. Therefore, AVF equals to VO upon, that is V output upon V input. We can write gain, voltage gain. Therefore, it's simply the ratio of output voltage upon input voltage. Therefore, is equals to minus, because it is inverting amplifier, minus, write these equations, put these equations. Therefore, minus IR2 upon IR1. Therefore, this equals to minus R2 upon R1. Therefore, this is the gain of inverting opamp. This is the gain of inverting opamp. So, this expression is derived. Then conclusions. Closed loop gain, that is AVF, does not depend on the value of open loop voltage gain. See here, in this expression only resistance R2 and R1, only these two values consists, not AV, that is voltage gain. Open loop voltage gain does not exist, therefore the closed loop gain does not depend on the open loop gain. Then closed loop gain can be adjusted by adjusting the values of, that means only closed loop gain only depends on the values of R2 and R1. And the output is an amplified inverted version of the input that we all know, that is, it is inverted amplifier. So thank you. This is our opamp as inverting amplifier with negative feedback. So this is all about opamp as inverting amplifier. Thank you.